Today on Ask This Old House.
And in most houses like this, 20 to 30% of the air in the ductwork never makes it to the living space because of small leaks like this. So today I'm going to seal the ducts from the inside.
That's next on Ask This Old House.
Mark, your house is just beautiful.
Thank you, Rishi. We love it here.
So what's up?
Well, we wrote to you guys about our heating and cooling system. It's a forced air system.
All right, I can see a supply register right here, and that's going to blow warm air in the winter right against the glass right there. That's good. You should have a return here somewhere.
We have a return right around the corner.
All right, so the air goes back to the furnace to be reheated right there. So what's up?
Well, we put a new furnace in about 11 months ago. We're hoping for a greater return on our investment. Our utility bills are much higher than we thought they'd be.
That's not good.
No, it's not good. And you know, the other big problem here is that we'd like to see more consistent temperatures in the house.
Inside the house?
Specifically upstairs.
Okay, well, you're not alone. A lot of people with a forced warm air system complain about being uncomfortable.
Yeah, it really has been. And you know, another thing we noticed is that it's just very dusty. There's just dust everywhere. It's very annoying.
Let's see what you got. Now, this ductwork is insulated, but it's not sealed. People see this insulation and say, oh, my ducts are sealed perfectly. Well, I've seen it so bad that when you turn on the furnace, all of a sudden the insulation blows up like that, which means the air's coming right out.
Right.
And it's a big deal in this country. You can lose as much as 20 to 30% of duct losses where it doesn't actually get up to the place you want to be.
Wow.
You're losing it to the attic, you're losing it to outside, you're losing it to the basement. So what I actually want to do is do something new. I want to show a technology where we can seal every bit of this ductwork perfectly from the inside.
Sounds great.
All right. Mark, say hello to Steve Taylor. He's going to help us seal the ducts today.
Hey, Steve. How are
Hi,
you?
Mark.
So how'd you get started?
So we've already started upstairs. We've sealed all of the supply and all of the return registers. So now any leakage that we measure is coming just from the ductwork.
Okay, great. And then you tested the ducts?
We did. We ran a pre-test.
Okay,
So we used the fan in this box
okay.
to blow air into the duct system and see how much air is going to leak out through the
So that pressurized the ducts, and you got it tied into the computer here. All right,
Correct.
so how'd we do? We lost 307 CFM, cubic feet per minute. And that's equivalent to a hole in your ductwork of about 58 square inches. That's a big hole.
Wow.
So let's do the math. 307 CFM, this is a 4-ton system. That's like just under 20%, right?
Correct.
Okay. So 20% is not coming back to be reheated. You're heating your neighbor's house.
It's unbelievable.
All right, so how do you seal the ducts?
So in order to seal the ducts, we need to do it as an aerosol. So we're going to use this sealant. We use the same fan that we used for the
Yep.
pre-test.
Yep.
We have a nozzle that injects the liquid into the duct. The small particles that are now in aerosol travels through this flexible duct here to a Y branch.
Gotcha.
Then it can go to the return and the supply, and we seal both at the same time.
You know, you got heated air coming out here. We want to keep that in the ductwork. Well, on the return side, it's under a negative pressure, so it's pulling air in. Remember you complained about dust?
Yeah.
Well, if these leak and there was any dust down here, it would be sucked into the ductwork and then distributed all into your house.
Okay. So all this happens from inside the ducts?
It does. We're not going to actually line all the ductwork. We're actually going to only seal where the breaches are, the breaks in the ductwork. So we might see a little bit leaking out from right here. In order to prove to you how it works, though, we're actually going to cut in a hole right here with a screen to really see it work.
Great.
So with this hole and the window screen over it, I've actually simulated some of the duct leakage you have upstairs in the building. So we all set to go, Steve?
We are.
Let her rip.
So we'll activate the machine.
Okay.
The fan will turn on, and it'll start to inject the sealant.
Here it comes. Right now, the airborne sealant is flowing through the pressurized ductwork, and it's squeezing out just where they have an opening in the ductwork. As it flows through those little cracks, it catches on the crack and actually coagulates to seal any duct leakage. Now, any of the sealant that happens to leak into the living space can be captured from this scrubber fan onto the filters. All right, well, we are done, and now I can actually show you just how effective this was. So instead of the hole, look at this. The window screen where the hole was is completely sealed, and that's really the same as all the leaks in your ductwork.
That's cool.
All right. So, Steve, what's our final numbers? How do we do?
Well, if you remember, we started off at 307 CFM,
yeah.
which is equivalent to about a 58 square inch hole in the ductwork.
Yep.
So now we're down to 19 CFM.
Under 20. Great.
And that's only a 4-inch square hole.
Well, this is what gets my attention right here, Mark. A 94% reduction in duct leakage. Does that work for you?
Yeah, that's great.
I think your whole system's going to work better, too. It's going to be more comfortable, more energy efficient, and it's going to be cleaner in the ductwork.
Great.
Thank you for your great work, Steve-O.
Thanks, guys. I really appreciate it.
Boy, I like the way that tightens up the system. That's smart.
It's unbelievable. It's going to be more efficient. It's going to be cleaner. But I think, as importantly, it's going to be comfortable. The air that you heated or cool gets to the right place. Now, think about what the challenge is. With metal ductwork like this, every time we have a longitudinal seam right here, this is not airtight. It's going to leak out through here. Every time we bring two pieces together, it wants to leak. How about this? These are both called takeoffs, where we'd come off of a branch right here. Now, these have metal tabs. Now, you cut a hole, bend the tabs. Well, that's not going to be airtight. The issue is we're losing 20, 30, 40% of the air that should be going into the living space for heating and cooling, going to the wrong place.
Wow.
I mean, think about it. Where we end up putting ductwork is where nobody really wants to go. The basement and the attic. And so that's places where when you lose it, you lose it.
Yeah. So something like this is perfect for a retrofit project like you're working on here. We've got
never
a lot of them.
I've never seen a better solution for fixing the ductwork.
All right. Well, good information and a great project.
Thank you.
And we've got plenty more of those coming up next time. So until then, I'm Kevin O'Connor
I'm Roger Cook.
I'm Richard Dewey.
And I'm Tom Silva.
for Ask This Old House.
You know, I really like this system.
You have a house in mind, I know. I know you. I know you.